enclosed by r equals 4 sine theta, and let's say that pi over 6 less than or equal to theta less than or equal to pi. So let me show you really quickly what this looks like. We could graph this by hand if we wanted to. I'm going to get out my graphing calculator, and under y equals, I'm still in parametric, so let's go to mode, go down. I don't want function, I don't want parametric, I want polar. So let's go ahead over to polar, and I'm going to hit enter, and I'm going to hit second quit. Now under my y equals, it doesn't say y equals, it has little r sub 1 equals, right? Which I'm not surprised by that, because the mode of my calculator is now in polar, so it's r. And guess what the variable button is going to put? Theta. Because r is based on theta. Just like for parametric, when I hit the variable button, it gave t, right? So I'm going to say 4 sine of, and I just hit the variable button and it gives me the theta. So R1 equals 4 sine theta. Now on my window, my theta min is pi over 6. And my theta max, what did I say, pi? And then it has your theta step, which, you could leave it at that, 0.13 something. So my x min and x max, I know that I have 4 sine of something, so let's go from -4 to 4 on both my x's and y's. And so let me go ahead and graph this. You guys ready? I hit graph, and here's what it looks like. That's from pi over 6 all the way there. So I'm going to take a picture of this, blow it up, and then draw on it. So this right here, this theta value, let me thank you guys again for being awesome. Theta 1, or alpha, is equal to pi over 6. And as it sweeps through, right, this would be pi over 2, and it keeps going, and then this is just pi. At pi, my r value appears to be 0. Do you see that? So at the angle pi, I'm back at the pole, or at the origin. And so this is the region. So it's like basically a part of the circle leaving off this little bit. But let's go ahead and do it using the formula. So I should say this. This is the other theta value. Theta 2 equals pi. So this goes right there, but then the r value appears to be 0. And we could plug that in by plugging in theta in for 4 sine theta. Sine of pi is equal to 0, and then times 4 is still 0. So sure enough, we see that at theta equals pi, the r value is back at 0, meaning that it's at the pole. Okay, so the area of this is equal to 1/2, don't forget that constant out in front, times the integral from pi over 6 to pi of r squared, so 4 sine theta quantity squared d theta. All I'm going to do is plug this into my calculator. You could, based on the nature of this, do this one by hand because you could, change sine squared theta and all that, but I'm going to just plug this into my calculator, so watch what I'm going to do, okay? So I go back to my calculator, I hit second quit. I'm going to clear this. Now check this out. I'm going to put 0.5 times math 9, which is the integral. I'm going to do pi over 6 as my lower limit of integration to pi of, watch, I don't want to write in 4 sine theta quantity squared because I'm lazy. So I do this. Bars, y bars, not function, but polar R1 squared. D, you just put the variable button and it knows theta because you're in polar mode. And you hit equals, and it's going to give you 12.204. Now, my guess is so this appears to be a circle. Do y'all see that? R equals 4 sine theta appears to be a circle with radius what?
I can help you find a place if you turn on location services.
No. 2. It's 2. The location is, it's up, shifted up so that the y value is 2 and the x value is 0 on the x and y axes, right, or Cartesian plane. So it has a radius of 2, a diameter of 4, but a radius of 2, right? So what I'm saying is, it seems like it's a circle without the first little, oh no, that's actually not a sector, never mind. This is it. That's all I want to do. That's it. 12.204 is the area of that thing. The area of the whole circle is pi times r, which is 2 squared, or 4 pi. So let's check out 4 pi minus second answer. So what was cut off there is approximately 0.3623 something. But the total area that they asked us to find was 12.204. Did that make sense? All right, good. Okay, here's one, and I'm going to okay, so I copied not just the example because we're getting kind of low on time, the example, but then also part of the solution. And so let's just walk through this example number 2. So they say, sketch r equals sine of 3 theta and compute the area of one petal. So find the area within one petal. So the tough part here is they do not give you the theta values. You have to determine the theta values. Well, where does it appear the center of this little flower, this little rose, is located? Where's the center of this little guy? Right at the pole, or at r equals 0, right? So one way to find where it intersects itself, why are you hitting yourself? Why are you hitting yourself? Why are you hitting yourself? is by setting r equal to 0 and find the different theta values that makes r equal to 0, and that's where the curve, right? Because it starts like this. If I were to trace it, let me choose something bold. So it goes right there, and then it hits because r is equal to 0 again, and then it goes down here, and then it hits because r is equal to 0, and then it goes up here, and then it hits because r is equal to 0, and then it keeps doing that over and over. It goes again and again and again. So all you're looking for is the area enclosed by one of these. Do you see how somebody's limits of integration might differ from someone else's or someone else's because they chose a different leaf? Right? So right there, let's go ahead and set sine of 3 theta equals 0 implies. So here we have sine of some angle is equal to 0. What is that angle equal to? Sine of what is equal to 0?
Pi,
0, pi, 2 pi, so 0 plus pi n, or just pi n, right? So what I just did is I ignored the fact that this was 3 theta, and I said sine of something equals 0. What's this something? Pi n. So therefore, 3 theta equals pi times n. Divide by 3, divide by 3. You get that theta equals pi thirds times n. So when n is equal to 0, you're at 0, and then pi over 3, and then 2 pi over 3, and then 3 pi over 3, or pi, and then, right? So I'm going to use theta 1 equals 0, and theta 2 equals pi over 3. So my setup is going to look like the area of one petal is equal to 1/2 times the integral from 0 to pi over 3 of something squared d theta, and that something is just what my r was, which is sine of 3 theta. Bum, 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 bum. Got it? Last thing I'm going to give you right now. What others would do is they would say, it sure looks like pi over 6 divides that up into two equal regions, or regions with equal area. And so what I'm going to do is I'm going to say that the area of one petal is equal to twice times 1/2 the integral from 0 to pi over 6 of sine of 3 theta quantity squared d theta. Are they right? As long as it is like that, where it's got that symmetry, yeah. You dig? So sometimes in the explanations for the solutions, he might go ahead and do that. Don't get confused if your limits of integration are different, but you have like, if they have twice and you only have one, but if you get the same answer, then it's all good. Okay. Tomorrow what we're going to talk about is what